provosts of all the 6 colleges, and they would either join us online or they are here with us, and then Blue Hammond Energy Center. Now, this program is organized under the Department of Materials and Metallurgical Engineering. We are honored to have the head of department, Professor Emmanuel Jikunu, with us here. Let's hear it for him. Without him signing off, this is not coming up. The department is also blessed. We have our tentacles everywhere in the university. So the current director of IDEAL, Professor, look at me and let me mention your name. Professor Anthony Andrews is also with us right here. Thank you so much for making it. We do have some staff members in here. Dr. Henry Agbe, who said the prayer, is also a staff member. We have some senior members with us. Please, I cannot mention all the names. You are all welcome. Most importantly, we have the chairman of this program, who happens to be the provost of the College of Engineering with us. And I'm going to call him in a bit to come and give us his welcome address and also opening address, so to say. But I just want to say a few things about our professor. First, personally, I had worked with him before, but I met him on a very nice day when he gave me a job to do, and that job changed my life. By the way, he even delivered the message to me, more or less saying, you better get it done. So I was at a program, he approached me. Naturally, I would have gravitated off because I didn't want to engage too much. I wanted to eat my food and walk away. And then he says, do you know that you would have to be the deputy project lead of KEEP? So then I turn and look again. I say, okay, now I have a problem to deal with. Clearly, he has a way to present things in a subtle way that makes a lot of sense. We are here, Grace, today, not because of just that, but he has done a lot of work with USID. He has also done a lot of work under the KEEP project I just spoke to you about. When it comes to academics, I mean, to be the provost of the college, you should have done a lot of work there. He also sits on a lot of boards, fellow of the Council of Members of the Ghana Institution of Engineers, and has contributed a lot to engineering profession here in Ghana. As we go on, we'll play some profiles of the work that he has done, but without wasting much time, I want to call on Professor Brichum, Kwabena Brichum Nyako, to give us a welcome address and then the opening address as well. Please, let's hear it for him.
Thank you, KMD. Professor Kwajumen Sandakwa, you failed to introduce yourself. Professor is also in the Department of Materials and Metallurgical Engineering and is also the Vice Dean for the faculty. We have our industrial partners here. We have Intertech. What's the name? Yes, Intertech. Is Intertech the main sponsor? Intertech, a warm welcome to you. We also have SGS, ELX, ICMS, and other industrial partners. We're expecting the regional director of EPA, director IDL, deans, HODs, and director IDL is also in the department, as has been mentioned already, Professor Anthony Andrews. Deans, I see Vice Dean, Professor Kwajumen Sandakwa. HODs, I see Professor Jikunu. Distinguished representatives of the Organization for Women and Science for the Developing World, OWSD. Representatives from government, industry, professional bodies, and academia. Faculty and staff. Researchers, students, invited guests. Those joining online are included. Ladies and gentlemen, good morning. It's my great pleasure and privilege to welcome you on behalf of the Vice Chancellor to the Mineral Wastes and Volarization Research Conference 2026. I'm delighted to join you as a special guest of honor and to welcome this distinguished gathering of researchers, industry leaders, policymakers, development partners, and students to the Kwame Nkrumah University of Science and Technology. I extend my sincere congratulations to the Department of Materials and Metallurgical Engineering and its partners, particularly the Organization for Women in Science for Developing World, for organizing this important conference. Your commitment to advancing cutting-edge research and fostering collaboration among academia, industry, and government is highly commendable. The theme for the conference, Volarizing Mineral Waste Through Engineering Innovation and Policy Advocacy, could not be more timely. It speaks directly to one of the defining engineering challenges of our generation: transforming mineral residue or waste from environmental liability into valuable resource that drive industrial growth, environmental sustainability, and inclusive economic development. Ladies and gentlemen, mining has been and continues to be one of the pillars of Ghana's economy. It contributes significantly to employment, industrialization, export earning, and national development. Today, however, the measure of success in mining extends beyond the volume of minerals extracted. It increasingly depends on how efficiently we utilize the resources, how responsibly we manage waste, and how effectively we create value across the entire mineral value chain. Indeed, waste can be seen as material in transition. Depending on your process, you may not want it. It may cause pollution, but it may also have some beneficial components. So how we manage that transition is important. Around the world, engineering innovation is demonstrating that mine tailings, waste rock, slag, and other mineral residues can be transformed into valuable products such as construction materials, industrial inputs, critical minerals, and other value-added products. Mineral waste is no longer viewed merely as an environmental challenge. It is increasingly recognized as an economic opportunity. Our responsibility is to accelerate this transformation through research, innovation, and collaboration. This vision of responsible resource stewardship resonates strongly with the strategic direction of the Kwame Nkrumah University of Science and Technology. Our vision is to be globally recognized as the premier center of excellence in Africa for teaching, research, and entrepreneurship in science and technology for development. Equally, our mission commits us to providing an environment for teaching, research, entrepreneurship, and community engagement to improve the quality of life. The College of Engineering continues to champion research that is academically rigorous, industry responsive, and solution oriented. We believe that research should not end in laboratories or scholarly journals. It must generate knowledge that solves societal challenges, informs public policy, drives industrial innovation, and improves lives. This conference is a clear demonstration of that commitment by bringing together academia, industry, government, and development partners to advance practical solutions for sustainable mineral resource management. Achieving this transformation requires more than scientific excellence alone. It calls for stronger partnership among universities, industry, government, and development partners. It requires policies that encourage innovation, investment that supports technology transfer, and entrepreneurs who are prepared to convert research outcomes into practical solutions that benefit society. I therefore encourage all participants not only to share scientific discoveries, but also explore how these discoveries can be translated into commercial applications, national policies, practical interventions that create lasting impact. I also wish to commend the organizers for creating opportunities for postgraduate students and early career researchers to present their work. These young researchers represent the future of engineering in Ghana and across Africa. Investing in their ideas today is an investment in the sustainable industries of tomorrow. Ladies and gentlemen, the discussions over the course of this conference speak to the kind of future we seek to build. A future where economic development goes hand in environmental stewardship, where innovation strengthens industrial competitiveness, and where engineering continues to provide sustainable solutions to society's most pressing challenges. As engineers, our success will increasingly be measured not by what we build or extract, but by the sustainability of the systems we design, the resilience of the communities we serve, and the legacy we leave for future generations. Permit me to conclude with this reflection. Mining should not be judged solely by the minerals we extract, but equally by how responsibly we manage the resource we leave behind. Engineering gives us the tools to transform waste into wealth. Innovation provides a pathway to a circular economy, and together they enable us to build a more sustainable and prosperous Ghana. May this conference inspire bold thinking, deepen collaboration among academia, industry, and government, and generate innovative solutions that will advance responsible mining, responsible mining, accelerate the volarization of mineral waste, and position Ghana as a continental leader in sustainable mineral resource management. On behalf of the College of Engineering, I once again congratulate the Department of Material and Metallurgical Engineering, the Organization for Women in Science for Developing Wealth, and all collaborating institutions for this excellent initiative. I'd also like to appreciate our sponsors once again. We have Intertech Mining Pro, ICMS, the Brew Hammond Energy Center. Which one again? ALX, I think I had ALX. SGS, yes. I would also like to appreciate the team that has put this together. Who is the chairman of the committee? Can we see the members? Show by hand so we can appreciate you. Or they are still working? Okay, then let's appreciate them. And one for our sponsors too. It is now my singular honor and pleasure to declare the Mineral Waste and Volarization Research Conference 2026 officially open. I wish you fruitful deliberations, productive networking, and every success through the conference. Thank you very much for your kind attention. God bless you all. God bless KNUST. God bless our homeland, Ghana. God bless our sponsors.
Thank you so much. Let's hear it for our provost. One more time, please. One more time. One more time. One more time. When you hear these wise words from our leaders, we don't take them lightly at all, because it is a charge for us to act on. And he's also coming from Katanga, so this one is a full charge. Are you okay? All right. Okay. So I know I have already spoken to our senior high school students, but we still want to recognize their presence here, because it is very important that what we do has a progression from the base and effectively going to be like a seed. So we have a few senior high school students here joining us, and we want to see you upstanding. Kumasi High School, if you are here with us, please let's show some love to them. You can have your seat. Thank you. KNUST Senior High School are also with us. These are our next door neighbors. Thank you so much. And one of them has gravitated to, I hope you are not trying to change schools. All right. Then we have St. Louis Senior High School also with us. Ladies, you're welcome. Note that this committee is chaired by a lady, and she has put a lot of pressure on us to bring us to this point. So there's a lot of work that you can do. Imagine that lady commanding this big man. You can understand. So thank you for making it. Otunfo said to the Second Technical Institute. They are also with us. Nice one. Nice one. Thank you so much for making it. Whilst we were receiving the speech from our provost, we also had the dean for School of Public Health, I think, Professor Peter Ejeba, for joining us. Thank you so much for making it. Look, when it comes to these programs in the university, you can see how important it is for the leadership to make sure that we have the right representation in order to move on. Let me just say that, do we have representation from women in engineering here? Women in engineering, they are coming. All right, that's good. I wanted to recognize them. And then Wisdom. Wisdom is here. Thank you so much for making it. Thank you. All right. So we have received wise words from our provost. He has given us a charge. A few words I heard that made sense to me: engineering, innovation, and pathway. If you fill in the rest of the equation, you would understand where he is driving towards. We will now want to take an address from our lead sponsors, and I will take a few minutes to read the profile. Please bear with me of the keynote address speaker. So his name is Mr. Samson Jesikoria. Samson has held various positions in Intertech Minerals across different parts of Africa, and was also the general manager of West Africa, Central Africa region, or West Central Africa region, prior to his current role. With over a decade of experience in geochemistry, he has technical achievements, includes designing, commissioning, and operating both commercial and on-site geochem laboratories. So under his leadership, at the Ghana Minerals business transformed from a struggling operation from 2015 into one of the company's strongest performing business in the region. The growth-driven approach has since been replicated across West Africa and Central Africa. And we have notable successes in Burkina Faso, Cote d'Ivoire, Ghana, among other nations. And might I say right here that we from KNUST make sure that our impact is felt within the sub-region, within Africa, and also in the whole world. With a move to SSA now, the passion and pace and precision with which he works has impacted East and Southern Africa. Samson is also a strong advocate of gender inclusion, having increased female participation in his teams by over 30% in the last 5 years. He is passionate about sustainability and actively supports community impact through corporate social responsibility initiatives. And I'm sure that is what drove him into making sure they sponsor this project or this conference. As a leader, Samson is 100% dedicated to his core team, championing growth, motivation, and reward. He leaves no one behind. He is recognized for his strategic leadership, operational excellence, and focus on sustainable growth. There's a note here about his passion, and I see it's important. Ensuring Africa stays a key business growth driver through relevant industry strategies, nurturing a high-performing team, being a poster for exemplary leadership and good business practice, and an employer of choice. So without wasting much time, we'll call on Ms. Edwina Corte to deliver the speech on his behalf. Thank you. Please, let's hear it for her.
Thank you. Thank you very much. Yes, so unfortunately, our business line leader couldn't make it, but then he has sent us to represent him. So we are doing this presentation together. So someone will start and then I'll take over. So I'll let him introduce himself before he starts.
Thank you very much. Yeah, KNUST graduates, they rock. She's one of them. Yeah. So, yes, I'm Samuel Tewia, and our keynote is in the form of a presentation. So I will start a company introduction, and she will take over something that is a bit more technical and related to what we're coming to do here. But leading our pack of the skin of Samson. So they said if the antelope doesn't go, its skin goes. So the skin of Samson is made up of 4 people here. Leading the pack is Mr. Yao Jan, who is our operations manager for West Africa. Yes. And I'm the business development manager for West Africa. And so Edwina is our HSSC lead, and my assistant Mildred is a business development associate. Okay. So I'm just going to do a bit of a company introduction and also show you what we do. It's not really geared towards marketing or business development, that stuff, but we want you to know what we do. Perhaps some of you may have need for our services, and then you will know where to get the solution that you are looking for. But before I start, just something about what was read about Samson and Intertech. Yes, we're really passionate about social responsibility. Just it was 2 weeks ago, right? We were at the Samahu Community Center within the Prestia Hinu Valley district to sponsor and partake in the judgment of a debate competition. And just before that, we had also attended a similar program. So we are passionate about social responsibility, but we are even more so passionate about those ones that are concerned about education, those ones concerned about research, and that is why we are here today. So our company, Intertech, is an Arctic company. We are in the Arctic space. So the Arctic is for assurance, testing, inspection, and certification. We are a big conglomerate headquartered in London with employees numbering more than 44,000 with more than 1,000 laboratories all over the world. So if you see the spread of the white dots, all the big white dots all over the map, these are the locations where we work all over more than 100 countries. And we are in this space of the assurance through the certification. We are the clear market leaders in the assurance part of the business, which is more concerned with process auditing, compliance, and brand protection and those kind of things. Right. So our services cut across products, the trade sectors, and the resource sector, and that is why we have a section that deals with mineral and geochemical analysis. Okay. Right. So through a depth and breadth of Arctic services, you can find us all over the place. We have one of our slogans that says, "You will be amazed where you find Intertech." Sometimes you may be amazed to see that maybe the microphone that I'm holding actually had to pass through a certification or a testing process through one of the Intertech labs. You may sit in an airplane to travel, and it may shock you to notice that Intertech, one of Intertech's operations somewhere, may have tested something about the engine that is running in the aeroplane also. So we really do an amazing work for the world. Right. So it's a very big company. We serve a lot of industries, but in minerals in particular, and for the West African sub-region, we have Intertech West Africa, and in Ghana, we trade as Intertech Minerals. And we are made up of a very diverse workforce of about 350 plus in our Takwa laboratory that is pictured here, sitting on about 5 acres of land. We're just one of those companies that is that huge, sitting on a sprawling green land within the Takwa environment. Those of you who know Takwa know that it's not easy to have that space, and we managed to have that. So that alone shows what we're doing over there. And we have sites all over the place. So we manage this commercial facility in Takwa. Then we have a sample preparation laboratory in Bolgatanga. We also have a lab in Yamoussoukro in Côte d'Ivoire. And we support on-site mine laboratories at Sambrado Mine, Bombori Mine in Burkina Faso, Mensen Mine, Bibiani, Perseus, Ayamfree, and so many others around the place. And these are supported by the regional operation hub in Takwa. And we have capabilities in sample preparation through fire assay, bottle roll through to metallurgical laboratories. I can confidently say we have competitors here. So for those of you who know about the Arctic space, you may know that some of the names that were mentioned, SGS, ALS, they are here. But I can confidently say that we are the clear market leader in Ghana, and we've offered the most comprehensive services that you can think of if you are a mine and you want to test, or if you are involved in materials and you want to know something about your materials. And whilst doing all this, we do it with speed and accuracy. And our accuracy is backed by our SANAS accreditation, which is an ISO 2017 accreditation. So we have our services in mineral testing, ranging from geochemistry, where companies start from exploration. They want to know the minerals that are existing in the samples. We do that for them, and while they are mining, we also do same. And then for environmental compliance, we also do environmental monitoring and assessment for companies. Yeah. All right, so I'll just take you through some of our advanced technologies that really let you know that if you bring some work to us, we'll be able to do for you. So on the environment, in the environmental space, we have a LECO analyzer that is used for carbon sulfur analysis, one of the most advanced you can find in the market. And we have bond weight index in Takwa, which is about comminution and grindability within the metallurgical space. And over there on the far right is ICP-MS facility. We are the ones with the only kind in Ghana that is. It's a photon assay, which is a non-destructive method of testing for minerals, typically gold, silver and copper and some other methods. So instead of the traditional methods like the fire assist and black, this one is non-destructive. So it uses X-rays to bombard your samples, and the characteristics emissions that the minerals in the sample give off is measured within this unit. In just about 2 minutes, you are done with your analysis. Very powerful technology. And Intertech is the very first commercial lab within Ghana to adopt this technology and give the services to the industry. Yes, so our environmental lab is also an accredited lab that runs through from water quality testing to soils to acid-based accounting and other things. So for those of you involved in the environmental space, we also have services for you. Yeah. So basically that is Intertech for you. One thing that we also pride ourselves in, you can see that we are a 50-50 gender share over here. I think it was mentioned that Samson is very passionate about gender equality and about diversity in general. So even though we are a lab, we have hearing impaired people that are working in our lab. They've been working there for so long. Our ladies, they said 30%, but I think now we sit somewhere about 50-50 in the lab. And they are not doing just like, excuse me to say, some administrative purposes. It's cuts across all over. People running the photon assay unit to the quality assurance unit. Ladies and gentlemen all mixed together. So that is Intertech for you. Now, I'll hand over to Mildred to take us through the part that is a bit more connected to the reason why we are here, the valorization. Thank you.
All right, thank you. So all of that was very important so that you can understand what we are coming to say about waste valorization technologies and circular economy strategies. We wanted to make this a bit practical, so we would first give a case study that we have worked on in our lab in Perth, Australia, and then we'll come down to some of the practical things that we do in our lab in Takwa. So a little definition about waste valorization and circular economy. As we know, circular economy is a regenerative economic system. It's more broad scale. That's the destination. We are trying to achieve circular economy by making sure that in our processes from production, use, and disposal, we are getting value at every stage of it. And then waste valorization is more specific to waste. So that is more like the roadmap, how we get to our destination. So what are some of the things we can do about our waste to make sure that we can get value, like our provost said in his address? Now, why does this matter? Why is waste valorization important? Why is circular economy important? First, I'll take it in 3 aspects. We have the first, that is like the commercial bucket. So waste to value conversion, it reduces waste disposal cost. We all know that it's really expensive to do waste management. My thesis here at Tech was in waste management, so I know how expensive waste management can be. Secondly, we have ESG graded reporting that a lot of investors and financiers are very critical about. So if you are a company that you can prove that you are sustainable and you think about the environment, there are some incentives that you can get. Then we have the operational bucket. So how can we make sure that we are reducing our carbon emissions? How are we lowering our operational cost? And how are we embedding circular economy thinking into how our sector works? And then third is planetary. I mean, how do we make sure that we are protecting the ecosystem? How do we make sure that we are protecting the environment? How are we combating global climate change? So like I said, first we'll take a case study that was done in our sister lab in Perth, Australia, and that was on carbon capture. When we say carbon capture, it's a climate technology. Basically, we want to see how we can trap CO2 emissions from the production process before it gets to the environment. So we don't want the CO2 to get to the environment, and then we are now looking for ways we can control it. So the carbon capture system basically just captures CO2 directly from their system. And here, well, the study was made mainly because we looked at our processes. When you go to Australia, the main thing that contributes to our scope 1 emissions is the ovens that we used. So you realize from what someone said, a brief about the lab, we use a lot of ovens because we need to do the sample preparation, dry the sample before it's taken through whatever process the client wants to take it through. So in doing that, we realize that we have a lot of CO2 that is going into the environment. So we have to find a way to control that from the very point. So what this system does is that it captures, it is fixed directly to the exhaust system. It captures the exhaust emissions. It is mixed with, well, from the research that was done, we realized that potassium hydroxide is the most cost effective, but you can also use sodium hydroxide or calcium hydroxide. And then once it reacts with the hydroxides, it produces valuable carbonate compounds. So these carbonate compounds can be used for soap manufacturing, glass production, cement manufacturing, fire extinguishers, lab fluxes, and then in the food and beverage industry. Like our provost said, the thing with waste valorization is making value from the waste. So if you are just finding a way to get the waste or manage the waste without actually making value, you are not really practicing waste valorization. So that's the point of carbon capture. It has a few economic and environmental benefits. From the study that we made in our lab, we realized that up to 37 tons CO2 can be reduced per year per oven, and then that we can get reduced greenhouse gas emissions. And this, generally, it would support the decarbonization of our mining lab. Economically, we realized that if we are able to sell the carbonate compounds that are produced, at the end of the day, we can generate from 17,000 to 42,000 USD per oven annually. So if you have 5 ovens, you multiply that by 5, and that's a lot of money generating for the company. Then we also have reduced carbon operational risk. I mean, a lot of times you have regulators coming, they want to see how effectively you are, how effectively your operations are benefiting the environment. So if you're able to do that, if there are any fines that will come up with pollution or something, that gets reduced. Then sustainability benefits. Basically, it converts an emission liability into something that you can actually sell and then produce money. So the key thing here is that the sale of the carbonate end products is what matters at the end of the day. Because if we are able to produce the carbonates and they just sit in a room, we are not getting any value. So that is the key success factor from the case study that was done. We'll come down to Ghana. So in Ghana, what we do on our lab to contribute to waste valorization and circular economy, I think I have about 3 examples. The first is recycling of plastic waste into useful products. Now, in most of our services, we have the plastic rubbers that clients bring. So most of the time, the samples that they bring are in these rubber bags. So what we do is that we collect them, and then at the end of the day, we send them to a recycling plant where we get recycled products like the baskets, the polythene bags, etc. that is used for export. You know, when you look at the waste disposal hierarchy or waste management hierarchy, I think recycling is the third. You go from reduce, reuse, and then recycle. So at least with this, we know that it's quite small scale, but at least we know that we are doing something that contributes to the environment. Okay, so the second is the second I mentioned from the waste hierarchy, reuse. So in our lab too, the water that we use in our processes, we have a treatment plant where at the end of the day, all the wastewater that is brought into it is recycled. So you can see from the pictures below, we are able to regenerate or re-get some of the water that we use in our process, and then we take it back to the lab and then use it in some of the processes there. At the end of the day, what this does is it reduces our fresh water consumption. So if ideally we'd use 5 tanks in a day, if we are able to recover about 2 tanks, it means that we don't have to get all the 5 from, the streams or wherever we have to get them from. And we know now that in our country, the issue of galamsey is really, really affecting our water bodies. So if we are able to preserve the little water that we use, then there's improved circularity. So the third I'll talk about is photon assay that my boss mentioned. He mentioned that, it's a non-destructive method where whatever samples the client brings to the lab is not affected by chemicals. There are no chemicals in it. So at the end of the day, we don't have any hazardous waste generated from this process. Apart from that, it also avoids the production stage emissions. Most of the chemicals that we use in our lab, so the flax and then the other chemicals that we use, if they are being produced, there are lots of emissions that get into the environment. So if we are moving to this technology, one of the things we do is to prevent or avoid that production stage emission. Then it also reduces or eliminates the high temperature furnace cycle. So in most of our labs, we use furnaces, and the furnaces use LPG, they use diesel. So there are also emissions that come from there. And if we are moving to a more green option, it means that we are eliminating the emissions that could come from there. And at the end of the day, there's less waste. The kind of hazardous waste you would get, like the coupels, the crucibles, all of that is eliminated once you use this. And we have 2 of them in Ghana, one in Asanko and one in Takwa, which shows how much we are trying to make sure that, our processes are green and sustainability geared. So still on the photon assay units, these are 2 different things that shows, what the conventional fire assay produces and then what photon assay process produces. So you realize that with the fire assay, you have the lead oxide flax waste, you have the nitrate solutions, you have acid digestion waste, and then you have the scrubber, the residues from the scrubber, because if you're using fume hoods and things, you have to make sure that you clear that up before it goes back into the environment. All that comes with a lot of money, all that comes with a lot of hazardous waste that could go into the environment. And if unfortunately you don't have a responsible lab that's, it's more particular about how they manage their waste, you realize that we'll be polluting the environment with all of these. So what photon assay does is that the original sample remains intact. It's available for reuse, it's available for further testing, and then there's no hazardous waste stream at all. So the most powerful circular economy move is not just about valorizing the waste, but then designing waste out of the process completely. I think that's one of the things that circular economy looks at. And that's one of the things that we practice in our company. Then this is still at the research stage, but we are trying to see how we can recover valuable metals or just get the clay stripped of the metals that could be in it. So this is the clay when it's not used, and then after it has been used in fire assay. So if we go back to the photon assay, what I was saying is that if you are using that, all of these waste materials are not produced because you have to use a lot of these in your processes, and at the end of the day, these could get into the environment. So if you're able to finish our research and find a better way of recovering the soil or the valuable metals, we are able to reduce hazardous waste. We are going to get, a possible revenue, reduce our disposal cost, and then just generally help the environment. The last thing I'll talk about, this is more sustainability geared than waste valorization, but I just want to point out that in saying that we are sustainability focused and green focused, we are also using solar equipment on our sites. So instead of taking all our electricity from the grid, we take about 30 to 40% of it from the solar energy we are able to get from the solar panels installed. So at the end of the day, what we are trying to do in all the things that I've mentioned is to improve our environmental stewardship, to reduce our operational emissions, and then to create value from our waste streams so that we can enhance sustainability performance for our mining clients. We know that we are not a mine, we are just a part of the process. So at the end of the day, if we are able to become green, if we are able to make sure that we valorize our waste, we are getting value from our waste, then we are also helping the mines in one way or another, because at the end of the day, whatever they are doing, in their production process, they know that they are not polluting the environment on our end of it. Thank you.
Let's hear it for Edwina and Samuel. From Intertech. And clearly, we needed 2 people to fill in for their boss, and they have done justice to it, rightfully so. So let's hear it for them. Shortly, we'll be taking a quick documentary from Intertech. So technical team, please work on that. But I just want to comment on a few things whilst we wait for that. Samuel said that there might be some competitors in here. We just want to put a disclaimer there. KNUST has nothing to do. We are neutral in determining that competition. Our interest is just in employ our students, our graduates, plenty of them, employ them. And whilst you are here, we just want you to know the other competitor is supporting KNUST, so you better come in and support us as well. Okay. All right, so the documentary is coming in soon. We were supposed to have a poetry recital. And yesterday, KNUST launched our 75th, it was, a launch of the 75 years of KNUST. We had a gentleman there giving a beautiful poetry. I tried to learn something quickly to do so, but it didn't work. So we'll use the documentary to fill in. Okay. All right, thank you. Let's listen in.
That waste are viewed as valuable resources. Across laboratories and industries, spent cupels and discarded batteries accumulate as waste, creating environmental and disposable challenges. At the Department of Materials and Metallurgical Engineering, a transformative research initiative led by Dr. Benita Kumsen.
Hello, and thank you very much for coming for this Mineral Waste Volarization Conference. My name is Engineer Dr. Mrs. Benita Kumsen and a 2023 OWSD Fellow.
A 2023 OWSD Fellow is demonstrating how urban mining can transform waste into valuable materials, scientific innovations, and opportunities for training future researchers.
So what is this work about? Basically, the fellowship looks at recycling of waste magnesium oxide cupels via compositional modifications for new cupel production.
What happens when materials considered waste are viewed as valuable resources? What happens when materials considered waste are viewed as valuable resources? Across laboratories and industries, spent cupels and discarded batteries accumulate as waste, creating environmental and disposable challenges. At the Department of Materials and Metallurgical Engineering, a transformative research initiative led by Dr. Benita Kumsen.
Hello, and thank you very much for coming for this Mineral Waste Volarization thank you very much for coming for this Mineral Waste Volarization Conference. My name is Engineer Dr. Mrs. Benita Kumsen and a 2023 OWSD Fellow.
A 2023 OWSD Fellow is demonstrating how urban mining can transform waste into valuable materials, scientific innovations, and opportunities for training future researchers.
So what is this work about? Basically, the fellowship looks at recycling of waste magnesium oxide cupels via compositional modifications for new cupel production.
Fire assay cupels play a critical role in precious metal analysis. However, after use, they become contaminated with lead and are often discarded as hazardous waste. To address this challenge, the project developed a process to remove lead from spent cupels using an environmentally friendlier organic leaching agent, including acetic acid and hydrogen peroxide.
So we started off with a reconnaissance with the assay laboratories here in Ghana, and as part of the scholarship or the funding activities, we were able to provide 4 students with some scholarship opportunities. These are Miss Lillian Diaba, Mrs. Lillian Jedu, who left the project along the line because she felt she had a better opportunity, Elliot Papo, Master Elliot Papo, and then of course Vincent Apia. So these awardees have been on the OWSD fellowship with me, working with me as research assistant.
The goal was not only to remove hazardous lead, but also to recover valuable material that could be reused. Traditionally, optimization studies require numerous laboratory experiments, increasing costs, time requirement, and exposure to hazardous materials. To reduce these challenges, material learning models were developed using data obtained from scientific literature and industrial manufacturing information.
So as we navigated the characterization, we saw that, these wastes have value, and so we cannot leave it like that. In fact, we wanted to remove lead from the waste or spent cupels and then be able to use the lead oxide that has been recovered in the assay process again, and then use the decontaminated spent fractions in the making of new cupels. But you see, it's not an easy task because removing the lead with green solvents is not a joke. So we went on leaching, optimizing all the process parameters, and we're able to come up with some good residue that we have been able to add locally available materials to it and have been able to produce the cupels.
This work was initiated by Elliot Papo and later completed by the internship team under the supervision of Dr. Benita Kumsin.
My research work currently focuses on the synthesis of geopolymer cement from fire assay slag for use as binder in cupel formulation. I started off by quantifying the slag generated by 3 fire assay companies in Ghana. I went ahead to characterize these slags to determine their chemical composition, mineralogical phase, and other properties.
Following lead removal, the regenerated cupel material was transformed into a new product. The internship team investigated the use of locally available materials, including sawdust, kaolin, and eggshells, together with the regenerated cupel material to formulate new cupels.
After our material preparation, the next step was the cupel formation. And to get the optimum cupel compositions and properties, we needed to build an AI model that will help us predict each cupel composition and also predict the properties, because manual iterations would have been costly and also wasted the materials available.
The resultant cupels were manufactured locally and evaluated for fire assay applications. The developed cupels were sustained.
Design and then probably easy and also by that I for
Equipment improved solid liquid separation during material processing and strengthened the project's local engineering capabilities. A custom mold system was also designed to compress and shape the newly developed pupils.
My name is Lillian Apenediaba. I'm a third-year MPhil Materials Engineering student. My research is focused on volarizing spent cupels to produce perovskite nanocrystal. So first of all, we collected some samples of spent cupels from some fair assay companies in Ghana, and then we crushed and then grinded some. And then we did a characterization analysis called SRF on them to determine the chemical composition. Because lead is the main focus of the research, you know how much of lead we have in the spent cupels.
Her work demonstrates how a hazardous waste component can be converted into high-value functional materials with potential applications in advanced technologies. Under the supervision of Dr. Benita Kumsen, undergraduate researchers investigated the recovery of critical metals spent from lithium-ion batteries and spent alkaline batteries.
During my undergraduate project, I was supervised by Dr. Kumsen on recovering of critical metals from discarded batteries from phones, laptops, and other electronic devices. Prior to this project, other literature normally rely on inorganic acids, which release hazardous chemicals into the environment. In the ships towards green sustainability, other works have explored single organic acids such as acetic and citric acid, but they require high temperatures and also hydrogen peroxide to achieve reasonable recoveries. These leads to high energy consumption, cost, and complexity in the system.
These studies have contributed to scientific publications and demonstrate the potential of waste materials as alternative sources of critical raw materials. Beyond technological innovations, the project has invested in people. Graduate students, undergraduate researchers, teaching assistants, and interns have all gained valuable experience in sustainable materials development.
Dr. Kumsen is a very good mentor, and she challenges students to think critically.
I'm Abubakar Rosapo Kamtanka, and I've worked with Dr. Benita Kumsen on different projects. But specifically, I worked on e-waste, which is waste printed circuit boards, and we worked on extracting silver from e-waste using green lixiviants. So with that paper, we've been able to publish the paper, and also we've been able to submit it to a conference in Bulgaria. Yes.
So working with Dr. Kumsen has been great and inspiring, even though it came with some challenges. One key thing I learned from Dr. Kumsen is the fact that she sees no limitations.
I have been able to visit various schools, senior high schools, teaching them about materials and metallurgical engineering, exposing them to other engineering fields. This journey has been an amazing one, right from the application period, where I was assisted by Professor Dankwa and of course Dr. Henry Agbe to be able to put together the entire application. Other strong women like Professor Priscilla Mante and then Professor Mercy Bedu, as well as Professor Vivian Professor Vivian, I can't believe that I have forgotten your name, but it will be scrolling down there. You have been strongly behind me during the application process for this OWSD fellowship. And thank God I was able to nail it. I was able to win this USD 50,000 funding to support my research work. A big thank you to the Department of Materials and Metallurgical Engineering, both the teaching and non-teaching staff, for the support that you have given me in this entire project.
Thank you so much. Let's hear it for them. And our sponsors are rolling now. Professor Vivian, we are sorry we forgot your name. Next time we will give her a teleprompter. Okay, so we'll move on with the program. We are a bit behind time, and the room is also full. So we're going to move on quickly. We're going to take our next keynote speaker. He is Dr. Jackson Edia Nyantechi, and he is an environmental scientist and a researcher. He has over 29 publications. He's the regional director of the Environmental Protection Agency here in Ashanti region. There are a few more things about him. In summary, he's an Amanfo in some sense of it. He's also KNUST twice. So he came here twice. So we appreciate that. He did some work in also China. He is a member of the International Association of Impact Assessment. He's also a Wesleyan, Christ in Tea. All right. Then he has done some work with UNE, our sister university. You know, they are our children. We give birth to them. And the thing is, when it comes to family life, he's there. And then his football is everywhere. He does Kotoko, then Chelsea, then like red, blue, white, Real Madrid, everything everywhere. But that's good. It tells his versatility. So without wasting much time, let's call Dr. Edia Nyantechi to give us a talk on policy, regulation, and industry practice in mine waste management. Thank you.
Thank you very much, Mr. MC, Prof. Chair. Please permit me to stand on the existing protocol already established. I'll see my senior here, Professor Ajibafo, who was my senior at MIMS Secondary School. You know, I started from MIMS Secondary School before coming to Prempeh. So I've seen him here and I feel so much being at home, let me put it that way. I bring you greetings from the Chief Executive Officer of the Environmental Protection Authority, Professor Anama Brown Kluche. In fact, looking at the importance that she attaches to this particular program, she would have loved to be here herself to give this kind of keynote address. But you know, being a politician, an equally important program has taken her somewhere. So I'm here with my colleagues, Lorizo, to represent the CEO, and then other colleagues are also here. Prof. Chair, distinguished participants of this very important program, I want to really commend the organizers of this program, especially Engineer Dr. Kumsen, for the effort that she has put in to bring me here. I've lost my senior brother, and the 1 week celebration was yesterday. When I called her that I will not be able to make, he said, no, Doc, you can't just disappoint us, so you have to be here. So right after the funeral, I had to drive to Kumasi to be here this morning. So I'm so grateful to you for bringing us here. I want to say that it's a profound privilege to stand before you today, not merely as a regional director of EPA, but as an advocate, a guardian and a regulator for our shared home. In fact, to be invited by this department that represents the intellectual conscience of Ghana's mineral resource management. On this day, where the entire world pauses to listen to you, to me is an honor that you've done to us. I'm therefore deeply honored and accept this responsibility to deliver this keynote address on this momentous occasion, as I will say. Prof. Chair, having sat down to listen to the previous speakers, I'm highly convinced that indeed our environment is safe. Because you all know that we define the environment as the biophysical elements of your surroundings. So it includes both the living and the non-living things. So we have the various constituents. We have the air, we have the land and the natural resources in therein. We have the water bodies and all these things. And at times we get worried when we realize that the output or the byproducts emanating from mineral processing end up in these fragile ecosystems. And for that reason, having sat down to listen to the presentation and the documentary, I'm highly convinced that indeed, based on your expertise and your commitment to protecting the environment is safe. So shall we put our hands together for ourselves once again? Waste valorization, in simple terms, is defined as trying to reset our mind to believe that the mine waste is not just waste, but it's a resource. For us, EPA, we have a terminology that we always use, and that is industrial symbiosis, where one industry's output or waste becomes the resource for another industry. And that is what we term as industrial symbiosis. So I'm glad to see this kind of presentation and this kind of forum where people actually buying into the concept of industrial symbiosis. So I'm so happy to be part of this very important program. But I strongly believe that this department has perhaps done more than any other department in the university to advance the science of what we extract, process, and discard from our earth. Let me begin with this fact that all the discussion that we are going to have here will anchor on. I just want to give some information that it would interest you to know that Ghana produced approximately 4.8 million ounces of gold in the year 2024 alone. And this was said to be the highest in Africa, and it was ranked 6th in the world. This is very wonderful. But don't forget that anytime we try to extract gold from the soil, the environment suffers. We destabilize the environment, and the waste streams that are generated also end up in the environment. So even though we are happy, but we still have some challenges therein. This figure climbed up to a record of 6 million ounces in 2025, which represents 21% increase. And this was driven by both industrial operations, a rapid formalization, small scale, or the small scale sector, let me put it that way. Gold now gives an account of 40% of Ghanaian total exports. Then we have more information to give you on this, but let us not read those numbers in isolation. Africa is a continent that contributes about 27% of the world's gold supply, with production exceeding 690 metric tons in 2024 alone. With that landscape, West Africa has emerged as the continent's dominant gold belt. Ghana, Mali, Burkina Faso, Cote d'Ivoire, and the others that actually contribute to what we have here. The ash gold cannot be left out. I want to say that in 2026 alone, Ghana climbed up 5 places to rank 7th in the world. And that is also very important information that we need to talk about. And let us also talk about the academia industry. The Kwame Nkrumah University of Science and Technology has been the intellectual backbone of Ghana's mineral processing sector for decades. And that is very wonderful. Its graduates populate and populate the technical departments of every major mining house operating in this country. Its research have been produced peer-reviewed work on gold beneficiation, tailings characterization, among others, are also very important to say to us. And then publications that you have also made are also very important. Despite all these, Ghanaians and some developing countries still do not see mineral wastes as a potential resource, but rather a useless byproduct that we also see. And that is the challenge that we have. Several mine wastes are generated, and some of these include the following. Let's think about the overburden, where the soils that sits on top of the ore is also removed and we generate waste from there. Can we also talk about the waste rock that we also have, and the tailings that we also have, and as well as the mine waste that we also generate? All these waste streams end up in the fragile ecosystem. So it means if care is not taken for us to address these issues, we will get the monies all right, but we will do it at the expense of the fragile ecosystem, which is also no good. Have you also talked about the acid mine drainage system that we have? So in short, what I'm trying to portray to you is that though we are extracting the gold from the soil, the economy is booming now, but the end result is that we are destroying the environment. For that reason, we need the policies that will guide some of these things that we are doing. Because there's this equation that we have, the environmental impact is directly proportional to population, affluence, or wealth, or technology. Now, we have no control over population. Now, people, our females and males are very fertile. They are giving birth to triplets, quadruplets that we have. So we have no control. Population has also failed us when it comes to environmental management. Then affluence, the economy is booming. People have money and they are developing. So that one too has also failed us. So the only thing we can rely on now is the technology that we have. So EPA, one of our major policies is that for you to develop, you need to have the best available technology in place to be able to manage the environment that you are destroying. So these waste streams pose a lot of environmental challenges, as I've already mentioned. The number one on the list is the acid mine drainage that we talk about. And it occurs when sulfide minerals in waste rock or tailings react with the air. You know, if you have your ore made up of sulfide, you expose the sulfide, it will oxidize into sulfur 4 oxide gas, combines with water, and you have sulfuric acid. Sulfuric acid will definitely give you a problem of acid mine drainage. So how do we use technology to ensure that we have these things also managed or mitigated in the environmental space? We can also talk about the heavy metal contamination from our tailings that we are also generating through our mineral processing, as well as the landscape alteration that we also have. Large volumes of overburden and waste rock permanently change the topography and can disrupt the local system. That is also there. So I want to put across 10 major questions for us to reflect on and also provoke us so that we come up with the best technology to be able to address this through valorization. The first question to you, to all of us here, how do we reset our mind for us to believe that the waste is a potential resource rather than a useless byproduct? How do we reset our mind, our thinking, to be able to do that? Let's think about that. How do we also come up with strategies to extract the gold and then also make use of the waste that we also generate? Let's think about that. How do we reduce the need for virgin materials and conserve the natural resources that we also have? Let's think about that. How do we also reduce waste to avoid environmental pollution? Let's think about that. How do we also support the circular economy that my sister presented on? By encouraging closed loop systems where the industry's waste becomes another one's inputs. Industrial symbiosis. Let's think about that. How can we think of subaqueous disposition You know, I talked about this issue where the sulfide component of the ore is exposed, oxidized, and then generates sulfuric acid to cause acid mine drainage. So in our quest to discard these waste streams, how do we do it? Can we think of where we do subaqueous disposition so that we reduce or prevent the sulfide from getting access to oxygen to get oxidized? How do we do that? Let's think through about this. Can we also think of treatment and recycling of processed water and carefully monitoring the wastewater storage facility so as to minimize environmental challenges? So these are the questions that I want us to reflect on as I move on with the keynote address. The things we are seeing currently did happen some time ago. Before 1972, some of these things were also happening. And then the people therein were challenged enough to organize a meeting at Stockholm, where remedial actions to be taken to address some of these challenges were also adopted. And then Ghana happened to be one of the participants. So whoever represented Ghana came back to debrief the president, and I believe that time it was General Kutu Echampo. And then he decreed, based on the NRC decree 239, for us to establish the Environmental Protection Council to address some of these things and then also advise the president on some environmental pollutions. Some of these things were geared towards addressing some of these environmental challenges that we used to have. So EPA came into being, and then in 1994, the late President Rawlings also directed Parliament to also change the name and give more powers to EPA. So it became Environmental Protection Agency at that time. And then based on the Act 490 at that time, EPA had about 18 plus other functions that we used to perform to ensure that some of these challenges are addressed and the environment is also protected for the current and the future generation. So the challenges we had in those acts were that, one, there were emerging issues like climate change. And I'm happy when a sister presented to that they are doing carbon capturing, and that is a plus for you. So it means that your operations are very green. So keep it up, thumbs up for you. I will tell Prof. CEO about this. So keep it up, that's good. Then the second one is that the emerging issues were not being addressed in there. Then climate change issues was also coming, and we realized that people were polluting, but the sanctions in the law were not deterrent enough to prevent people from polluting. Therefore, on the 6th day of January 2025, the president assented a bill that was before him to be passed, and then we have the name of Environmental Protection Agency changed into an Environmental Protection Authority. And the reason is to give us more powers and more mandibles in biological terms to be able to chew bones. Yes. Before then, the assembly school sits anywhere at their comfort zone and then change the use of an existing wetland into other land uses without recourse to EPA, and they will come in and impose those things on EPA. With a new law, the EPA, or the Environmental Protection Act 1124, the EPA has this power. If in the opinion of the authority, the rezoning process or the permitting or taking on the said ecosystem will pose serious threat to the environment and the human lives, EPA now has the powers to revoke the rezoning that has been done. To me, this is a very wonderful thing that we all have to put our hands together for the lives. Apart from that, you also have laws with some stringent sanctions therein to prevent people from polluting. And one of them is geared towards the large scale or small scale mining that is producing those mine wastes that we do not have control over. One of them is what I've talked about, the Environmental Protection Act 1124, 2025. This one gives us the mandate to monitor and then also to permit all such undertakings. And you know, when we give the permit, you subject the process through EIA, Environmental Impact Assessment. And then based on your commitments that you are going to make, then we'll give you an environmental permit with some stringent permit conditions. What it means is that if you're able to work within the confines of the permit conditions, then the environment will be protected and everybody will be safe. That is what we do. So we have the law backing us and the policy backing us also to do this kind of thing that we are talking about. Then we also have one that also targets the emissions into the atmosphere. The LI 2507 is also there. It's been established. Now, whatever releases that you are going to have into the environment, into the air, to compromise the air quality, make sure you contain. If you, in the absence of that, then we'll invoke the relevant sanctions of the law, and then you'll be in trouble. So the LI 2507 has also been passed as a policy to guide some of these things. Other than that, the atmosphere will be saturated with carbon dioxide and other things that we are talking about. I keep saying that when you look at the sequence of creation, during creation, the way God created the heavens and the earth, he did this in such a way that the system itself was able to regulate itself to ensure that there's sanity in the environment. So I keep saying that from basic science that we learned from school, we were told that air is a mixture of gases. And we have carbon dioxide, we have nitrogen, we have oxygen, we have rare gases, and all those things there. Now, God, in his own wisdom, knows very well that man will have to depend on the available oxygen to be able to oxidize the food that you take and break them into energy in the form of adenosine triphosphates, so that you always have the energy to think, energy to sleep, energy to do whatever you are doing. That is how he made it. And then man, in the process, will give out carbon dioxide that will also go out there. And if care is not taken, it will go and compromise the air quality to create another phenomenon called climate change. So in his own wisdom, he decided to put the green plants that we have there, the vegetation that we have there. So when we breathe out the carbon dioxide, instead of ascending into the atmosphere to compromise the air quality, the green plants that are available will also absorb them in the presence of sunlight and water, and through photosynthetic activities will produce carbohydrates for us, so that we get the cassava, the mancani, and those things that we can also live to survive. And that is how God made his system. And he made it in such a way that the carbon dioxide that is not needed was put at a lower concentration. That was 0.02 milligram per liter, or ppm. That was how he made it. And the oxygen that we also depend on, he put the concentration as 21% of the composition. Now, recent publications show that the levels of carbon dioxide in the atmosphere have doubled, which means that the concentration is around 0.04 ppm. And the levels of oxygen that we also need has also reduced. It's gone to 20.95% instead of 21%. So I keep saying that if we are to have the lives of people with bigger nodes who can siphon all the oxygen that we have there, then some of us will suffocate and then also die. But that is not how God wants it. So it means that if nothing is done about this thing, it will get to a point that if God decides not to destroy the environment again, we ourselves will destroy the environment, and that is it. So we have to do something. We need to take remedial measures to address some of these issues. And that is why EPA is also there to address some of these things. Because the things that we are doing, the illegal and the irresponsible mining that we are generating volumes of waste into the system. So how do we ensure that we valorize these waste streams so that we can make good use of it and then also reduce pollution? And that is why EPA is also there. Now I tell you, if we want to use our own wisdom to ensure that we do clean up, it will be too expensive for us to bear. You all heard of the chemicalization that we talked about, where we are using copper-based nano technology to treat the water. It's very expensive, and that is something that we don't encourage. But we are compelled to do it. It's because of the irresponsible way we are doing our mining. So the laws are there. We've had enough policies, we have enough laws. We've now had enough allies, we have enough regulations. How do we enforce these laws so that our environment will be clean? To me, we have to depend on you. We will need the data from you, the research findings from you, to make an informed decision. And I believe that together we'll be able to have a better Ghana for us. On that note, I thank you so much for this glorious opportunity, and may the Lord be with us.
Thank you so much, Doc. Please, let's hear it for him. Let's hear it for him. We'll move on. We'll take our last keynote address, and then we'll go for breakfast. It's hot. But let me just try and summarize a few things. Time is not, but let me say it this way. Look, our IT people, I hope we can transcribe what he has said. We're going to take his speech as well. And the challenge really is to our senior high school students. And I'll tell you a story, and then we'll call the next performer. Look, somewhere in 1959, 29th of December, there was a gentleman, his name was Dr. Richard Feynman. He had a talk at the Caltech, California Technical Institute. That was the American Physical Society that had met. And then he told them, he had a talk about something called there is plenty of room at the bottom. At that time, he predicted some things to them and gave them a challenge. Today, when you listen to what Dr. Nyantechi said, he actually listed some things for you, what you probably will call problem of the day now. And I want you to take them and try to see what you can visualize, what you can do in the future, because some of the things that Dr. Feynman spoke about later on was proven to be true, and that was what gave birth to nanotechnology. And he gave some challenges to the people over there. When you read more, the professors like us who were there, white-bearded, not white enough, thought that this guy is just telling us too much rubbish. However, the young people who didn't have any box to think around but thought wildly were actually able to complete his task, and he had some monetary amount on it, and they won it. So hopefully Intertech and ALS will put something on some of the things he said, talking about how we take gold and use it, how we conserve the natural resources we have, how especially waste should be an input for another process. So please, let's have it for Dr. Nyantechi. Thank you so much for your insight. We'll quickly take a poetry recital from Samuela Ajua Kranchiwa Befi on value in the dust. Value in the dust. Please come in.
In 2023, a fellowship was won, not merely for a project, but for a journey begun, a journey that looked beyond the assay, beyond the glitter of gold, to a humble pupil, won and spent, with another story to be told, and from what remained, a new pupil could prove. Where others saw residue, she saw possibility. Where others saw an ending, she imagined sustainability. Lead was the problem, a challenge, and from what remained, a new pupil could prove. There is an old saying that says, a tree that bears good fruit must survive the storm, and the labor of the greatest scientist is not about challenge, it's not about material, it's not about publication, it's about people. And today, we celebrate more than a fellowship, more than a challenge, more than a project. On this day, we honor Dr. Beneta Kumsin, who has transformed waste into value and has helped inspire the life of others. Thank you.
Thank you so much, Samuela. Let's hear it for her, please. Let's hear it for her. So I was rushed off so she can come in, but one thing I wanted to add is don't forget this date, the 25th of June. That is why I gave you the date where Dr. Feynman actually had that speech. And today we refer to that day that it was the start of nanotechnology. Ladies and gentlemen, we have our last keynote address that we'll take. I don't think I need to introduce her. There has been a lot of talk about her already. But one important thing you should know is that she is the only female in our department. So sometimes it's not only numbers that matters, because She actually controls a lot of power in that department. When she says we move, yes, and we call her pressure, because he would give you the pressure, you would move. So please let's welcome our OWSD Fellow 2023, Dr. Mrs. Benita Kumsen, to give us a speech on characterization, sustainable processing, and environmental management of mineral waste. Pressure, you're welcome.
Boss, thank you very much. Can we give him a round of applause? Thank you so much. And I'm very grateful to be here this morning. Conference chair, distinguished conference chair, my own provost, and then that's Professor Brichum Nyako. And in fact, Prof, can I stand on the already laid? Yes, thank you very much. But I cannot go ahead also without saying thanks to some really strong people who have been here for me. I can see Prof. Andrews. I'm hoping that I'm able to deliver my message well because he is my boss. Yes, thank you. All right, so I looked at what was given to me and I had to restructure it a little so that I can capture urban mining, the needful strategy for sustainable metal recovery. And today I want to invite you to undertake a simple but a revolutionary shift in thinking. And already the speakers who came ahead of me have laid some good foundation. And I'd like to create two scenarios. Imagine two miners. The first miner travels deep underground, drills hard rock, blasts ore using different kinds of explosives, transports tons of material, processes it, and ultimately recovers a few grams of valuable metal. Now, the second miner walks into a landfill, an assay laboratory, an electronic waste collection center, or a metallurgical plant, and recovers metals that have already been mined, processed, consumed, and then discarded. You realize that the first miner works on a resource that is becoming increasingly depleted. But then the second one works on a resource that grows every day. That is what we refer to as urban mining. Please, can someone control my slides for me? Okay, I will do that. So urban mining is more like an above ground kind of mine. So instead of traveling into the bowels of the earth, we look at what we have already recovered and see how we can make use of it. Because day in and day out, we throw away materials. So why urban mining? Ladies and gentlemen, human civilization is accelerating toward an unprecedented demand for minerals and metals. In fact, if you look at yourself, the ladies here, everybody is wearing some sort of earring. The gentlemen are also wearing wristwatches. In fact, I want to say that metals are very important. You are sitting on seats. They are made from metals. Is that not so? Everything in life is a material and has a certain composition. I always say that God is the best kind of metallurgist I have ever found because he's able to cause even our very bodies to interact very well. Calcium, tissues. You realize what I'm saying? Your very teeth are calcium-based. So global transition to renewable energy technologies requires enormous quantities of copper, cobalt, lithium, nickel, silver, manganese, rare earth elements, and numerous other strategic metals. Electrical vehicles now require various minerals, wind turbines, solar panels, and so on and so forth. So you realize that urban mining is very, very important. What is my journey into urban mining? My own journey into urban mining did not begin with waste. It began with environmental concerns associated with mining. My early research investigated arsenic mobilization in mine tailings and the development of remediation technologies using iron oxide materials. These studies deepened my understanding of the environmental consequences of mining residues and waste mismanagement in general. As my research evolved, I became increasingly interested in a fundamental question. Which question is that? Can waste generated by mining and metallurgical industries become resources rather than liabilities? This question led me into work involving beneficiation of metallurgical slags, where I recovered iron oxide for heavy metal removal. Not only that, these iron oxides have proven worthy when it comes to arsenic, lead from even galamsey polluted water. That tells us that urban mining is very important. A defining milestone in my journey was my selection as an OWSD Early Career Fellow. That was in 2023, under the Organization for Women in Science for the Developing World. And it's a UNESCO program supporting exceptional women like myself from developing countries. For me, the OWSD Fellowship represented much more than funding. It represented trust. It represented recognition. It also represented an opportunity to transform an important environmental problem into a circular economy solution. The grant number is 44500501094. And I want to mention it because I see the strength it has given me. My passion in mentoring young people. My passion in valorizing waste. Sometimes one student just left because she thought that it was lead that we were dealing with, and it was quite poisonous. And I say here today that yes, it has been a poisonous journey, but it is worth it because we have been able to recover the lead, not entirely, but we have started, just like Prof. Kwejomen Sadakwa said, on the 25th of June, some years back, nanotechnology was birthed. Today, 25th of June, it wasn't birthed at that time. It was launched. The launch into urban mining here in Ghana. Thank you very much. So what is it that I do? And because of time, I'm just going to run through quickly. Oh, I think these slides, so they are not appearing well here, but I'll mention it. So I work on QPELs. I work on spent slag. I work on spent batteries. Currently, I'm venturing into spent photovoltaics. How do I do it? The word characterization is very important. We are only able to mingle with ourselves because we identify a character in one person or the other that we can cope with. So identifying the nature of every waste material is key to urban mining or mineral waste valorization. What do? We basically use steps like XRF, X-ray fluorescence for elemental characterization, XRD for mineralogical identification, because you may identify elements, but how are they associated? So SEM combined with EBS would help us understand morphology and association. Sometimes that technique can also help you to know the specific elements that are in that particular body. Not only that, we dissolve something called acid digestion. Aqua regia, Intertech is here, they know what I'm talking about. And then you use an ICP-MS, ICP-OES, or an AS. Now it is phasing out. You heard about the photon assay. that is used to determine the elements that are present. I am very happy to be with the Department of Materials and Metallurgical Engineering because they made me understand that before you can work on any material, you should understand its structure. The moment you alter the structure, the material will give you a certain kind of properties. So even while I was working on the cupels, I spoke to Prof. Andrews a few weeks back, and he said, why don't you consider metakaolin? It's just about changing the phase using heat. And then its properties will change and give you, because we had gone to ALS to test the samples, they worked, but then we had to come back and correct it a little. And that was the idea he threw in. And we started working on that. Have formulated new ones yet to be tested. So when it comes to urban waste management or urban mining or mineral waste valorization, understanding the characteristics is key. Not only that, you look at particle size analysis, because you can all attest to the fact that when you have rocks, they fit in a unit differently. When you have sand, they also fit in the same unit differently. In fact, you can pack more sand than rocks. So knowing all these things help us to valorize waste. I'm just skipping so that we can go on. My final call to action, even as I conclude, is this. To researchers, please help us develop recovery technologies, not merely the characterization techniques. And so you know that this property is made up of these elements, this morphology and all of that, and so what? To our university, please help us to build centers of excellence in urban mining and circular economy research. And as you can see, I have begun that. And very soon, as I learned from Professor Mercy Badu, it's all about the picture you have in mind, and we would get there. To policymakers, and I'm happy that Dr. Yantechi is here, please help us to create incentives that make secondary resource recovery attractive and profitable. And to my dear students, thank you so much for coming. The future miner may be wearing a laboratory coat, not a hard hat, because we may not end up going underground again. Vast lands have been destroyed. Let us learn to make use of the resources that we have. Ladies and gentlemen, the 20th century has taught us how to extract resources from the earth. The 21st century must teach us how to recover resources from what we have already obtained in the past. Urban mining offers us a future where economic development and environmental stewardship work together rather than against one another. The richest mine of the future may not lie beneath our feet. It may already be sitting in our cities, our industries, our laboratories, and our waste streams. Thank you very much for coming, and I hope that as you go, especially the young ones, you join us at the College of Engineering.
All right, let's hear it for her. Let's hear it for her. Let's hear it for her. I don't think I need to give any summary on this, right? At all. She has actually labeled everything clearly, and hopefully we have something hidden somewhere to take home. And I also don't want to be the one standing between you and the prepared breakfast. So we would quickly break up and go and have our breakfast. We would have poster sessions, interact. The provost is here. Have some interaction with him. We have some of our professors here, interact with them. Students, interact with our industrial partners and make sure you make some connections. So we break up and then go and have something to eat. My name is Professor Kojomen Sadakwa. Prof, that was the plan, to mention my name at the end. All right, thank you all so much. And we'll break out to the various rooms to take the other part of it. Prof, thank you. We will take pictures by, what do you call that thing?